In recent months, more and more analysts, investors, and technology observers have come to the conclusion that humanity may be only a few steps away from the largest transformation since the emergence of the internet. If at the beginning of the 21st century, the main symbol of the technological revolution was the smartphone, and later, artificial intelligence, then many now consider the next stage to be the arrival of mass-produced humanoid robots. And we are no longer talking about industrial machines behind factory fences or robot vacuum cleaners, but about fully human-like assistants capable of living alongside people, understanding speech, maintaining conversations, carrying out tasks, and making independent decisions within the limits of their assigned functions. For many years, such ideas were considered elements of science fiction. Hollywood showed us worlds where humans and robots coexist side by side. But most experts believed that such a reality was still decades away. However, the situation began to change rapidly after breakthroughs in the field of artificial intelligence. What used to be the main challenge of robotics, the ability to understand the surrounding world and adapt to it, is gradually ceasing to be an insurmountable obstacle. Modern artificial intelligence models can already analyze images, understand speech, conduct complex conversations, write code, plan actions, and learn new tasks much faster than just a few years ago. Against this background, increasing attention is focused on Tesla and its Optimus project. This robot is now seen by many analysts as one of the leading candidates to become the first mass-market humanoid assistant. In recent years, the company has repeatedly demonstrated new versions of the robot, showing improvements in movement speed, manipulation accuracy, and autonomy. Many investors point out that Tesla is not simply building a standalone product, but an entire ecosystem in which vehicles, artificial intelligence, energy systems, and robots can operate as a unified platform. However, another idea is being discussed more and more often among analysts. Many believe that today's humanoid robots are only an intermediate stage, just as the first mobile phones were merely preparation for the smartphone era. Today's robots may only be a step toward the emergence of a completely new generation of human-like systems that will be much closer in appearance and behavior to humans than anything that exists today. According to information regularly appearing in technology media, many of the world's largest companies are simultaneously working on the task of creating highly realistic humanoid platforms. Their goal is not simply to build a machine with arms and legs. The goal is much larger: to create a machine that can naturally interact with people in everyday life. Imagine an ordinary morning in the middle of the next decade. You wake up not to a smartphone alarm, but to the quiet voice of a home assistant. The robot already knows your schedule, tracks changes in your calendar, checks the weather, traffic conditions, and news. While you get ready, it prepares breakfast, responds to incoming messages, and reminds you about important meetings. Everything happens so naturally that after some time people practically stop perceiving such an assistant as a technological device. This effect is exactly what many researchers call the main feature of the future robotics revolution. When technology becomes part of everyday life, people quickly stop noticing its presence. Today, nobody is surprised by a smartphone in a pocket or a voice assistant in a smart speaker. In the same way, one day having a robot in the home may become completely ordinary. According to forecasts from several research companies, the humanoid robotics market could potentially reach tens of trillions of dollars in the long term. The reason is simple. Unlike cars or computers, which solve a limited range of tasks, a humanoid robot is capable of performing thousands of different functions. It can work at home, in a store, in a hospital, in a hotel, in a warehouse, in an office, at an airport, or in manufacturing. A particular interest is focused on the question of the artificial intelligence that will control such systems. Many experts believe that AI is the main missing element of the entire structure. A robot by itself is only a mechanical body. Its true value appears when this body receives an intelligent control system. A possible scenario looks like this. A person comes home after work. The robot greets them at the door, helps carry groceries, provides updates about deliveries and events of the day. During dinner, it can maintain a conversation, explain complex topics, help children with learning, and act as a personal tutor. At night, the system continues working, monitoring home security, keeping track of household devices, and performing tasks that do not require human presence. For elderly people, the importance of such technologies could be even greater. Many countries are already facing aging populations. Millions of people live alone and need constant assistance. A humanoid robot could remind them about medication, monitor health conditions, call emergency services when necessary, and simply provide a constant presence nearby. However, the more realistic such a picture of the future becomes, the more questions arise. One of the main ones is how quickly society will be able to adapt to the mass appearance of human-like machines. History shows that people adapt surprisingly quickly to new technologies. What seemed like science fiction yesterday becomes normal a few years later. Many analysts suggest that the first years will be accompanied by a period of universal curiosity. Robots will attract attention on streets, in stores, and in public spaces. People will take photos with them, discuss their capabilities, and compare different models. However, after some time, a stage of everyday normality will arrive, when having a robot will become as common as owning a car or a laptop. At the same time, there is another side to the issue. The more realistic machines become, the more social relationships will change. Some researchers warn that part of society may begin forming emotional attachments to robots. It is already known today that users can emotionally react even to relatively simple digital systems. If we are talking about a realistic humanoid capable of understanding the context of conversations, remembering a person's preferences, and maintaining years of interaction, the effect could be much stronger. Another topic of discussion is employment. Robots could transform the labor market across almost every sector of the economy. If the technology truly becomes widespread and affordable, companies will gain the ability to automate a huge number of tasks. This could lead both to higher productivity and lower costs of goods, as well as to the need for a large-scale restructuring of the employment market. Some economists believe that the world will face the largest redistribution of labor since the Industrial Revolution. New professions will appear related to managing robots, training them, and maintaining them. At the same time, some traditional occupations may gradually disappear. A separate question concerns the cost of such systems. Today, creating a sophisticated humanoid robot is extremely expensive. However, the history of technology shows that mass production can dramatically reduce prices. The first computers cost millions of dollars. The first mobile phones were available only to a limited number of people. Today, similar devices are used by billions of people. Therefore, many analysts assume that the initial price of an advanced home robot could reach tens of thousands of dollars. But as production volumes increase, the cost will gradually decrease. In the long term, the price could approach that of a mid-range car. Future cities could also change beyond recognition. Imagine streets where millions of robots of different models move around every day. Some work as delivery assistants, others help tourists, others provide security in public spaces, while others handle technical maintenance of infrastructure. New traffic rules, new safety requirements, and new standards for interaction between humans and machines will appear. The legislation of most countries is not yet prepared for such changes, so many experts expect long discussions between technology companies and regulators. The issue of responsibility is especially complicated. Who is responsible for a robot's actions? The manufacturer, the owner, the software developer? These questions are already being discussed in legal circles in many countries and will likely become one of the main topics of the next decade. Some futurists go even further and suggest that the widespread adoption of humanoid robots could change the very structure of society. If machines take over most routine work, people will be able to devote more time to creativity, education, science, and personal development. Other experts, on the contrary, warn about possible social disruptions and the need to adapt economic systems to a new reality. Interestingly, many of the world's largest investment funds are already viewing robotics as the next major trend after artificial intelligence. Capital is gradually moving toward companies operating at the intersection of AI and robotics. That is why every new demonstration of the capabilities of modern humanoid robots attracts such strong interest from the markets. At the same time, it is important to understand that a significant portion of the loud predictions and rumors remain exactly that, predictions and rumors. At the moment, there is no public confirmation that any company has already created a humanoid robot that fully surpasses humans in intelligence or is ready for mass deployment on the scale of millions of units. Nevertheless, the speed of technological progress in recent years is forcing many analysts to revise their previous expectations. In recent months, more and more rumors, leaks, and reports from sources close to Tesla's supply chain have been emerging around the Tesla Optimus project. While the entire world is watching Tesla prepare for the mass production of humanoid robots for its own factories, the industry is increasingly discussing a completely different direction for the project's development. This is not about a home robot, and not even about standard industrial automation. According to several analysts who track Tesla's component suppliers, Elon Musk's company may be working on creating the first truly heavy industrial version of Optimus, designed to perform tasks that today require specialized machinery, forklifts, construction cranes, and large industrial manipulators. According to discussions in professional circles, the idea appears quite logical. If the current Optimus is being developed as a universal humanoid assistant with a human-like height, then the next stage of evolution could be a significantly larger platform. Engineers have already proven that they can create efficient electric actuators, compact power systems, powerful batteries, and software for coordinating movement. The next step could easily be scaling these technologies to a much larger level. This is why in recent weeks more and more speculation has emerged about a project that some insiders are informally calling Optimus Industrial. According to unofficial information, such a robot could have a height of around 3.5 meters, and in some configurations could even approach 4 meters. Its weight could exceed 2 tons, but thanks to new materials and more powerful actuators, it would maintain high mobility. Its main feature would be completely new power systems developed specifically for heavy industry. While the standard Optimus is focused on carrying boxes, parts, and performing everyday tasks, the industrial version could work with loads weighing several tons. According to some experts, the lifting capacity of such a platform could reach 5 to 10 tons depending on the configuration. Many analysts draw comparisons with how Tesla once transformed the electric vehicle market. The company first created a niche product, then gradually scaled the technology and brought it to the mass market. A similar scenario could now be unfolding in robotics. First come humanoid assistants for Tesla factories, then mass-market robots for businesses, and after that specialized versions for heavy industry, construction, and logistics. According to information discussed in investment circles, one of the main tasks of such a robot could be working on construction sites. Today, many construction processes remain extremely labor-intensive. Moving heavy materials, installing metal structures, transporting equipment, unloading trucks, all of this requires large numbers of workers and specialized machinery. A humanoid robot capable of performing such tasks independently could change the entire economics of construction. Imagine a construction site of the future. Instead of dozens of workers, several autonomous robots lift a heavy beam. They do not get tired, do not require breaks, can work around the clock, and coordinate their actions through a unified artificial intelligence system. Each robot receives data from a digital building model in real time and knows exactly where every component should be placed. This concept is already actively discussed in engineering communities and fully matches the long-term vision of automation that Elon Musk has repeatedly described. Another potential application could be next-generation factories. Today, many industrial facilities use huge robotic arms fixed in one location. They are extremely efficient, but they have a major limitation: a lack of mobility. The humanoid industrial robot could move freely around the facility, perform dozens of different operations, and adapt to changes in production processes without the need for expensive reconstruction of the entire production line. Some analysts believe that such systems could become especially valuable in metallurgy, mining, shipbuilding, and the aerospace industry. These are precisely the sectors where companies regularly deal with extremely heavy components, while employee safety remains a serious challenge. A robot is not affected by extreme temperatures, toxic substances, intense noise, or hazardous environments. It can perform tasks that pose significant risks to humans. The potential intelligent component of such a project deserves special attention. In recent years, Tesla has made significant progress in artificial intelligence through the development of its own computing systems and supercomputers. Many experts believe that future versions of Optimus will not rely only on pre-programmed scenarios, but will use advanced AI models capable of independently analyzing situations and making decisions. If such technologies are integrated into a heavy industrial platform, this could lead to the emergence of a fundamentally new class of machines. According to discussed forecasts, an industrial Optimus could be equipped with hundreds of cameras, LiDAR systems, ultrasonic sensors, and pressure sensors. Its perception system would allow it to create highly accurate 3D maps of the surrounding environment. The robot could recognize tools, materials, vehicles, and even predict the actions of other participants in the production process. Some sources suggest that Tesla may use the experience gained from autonomous driving development to train future robots. Essentially, if a vehicle learns to understand the surrounding world through cameras, the same approach could be applied to a humanoid platform. The difference is that instead of moving on roads, the robot would navigate inside factories, construction sites, and warehouse complexes. The question of such a robot's strength is particularly interesting. Various analytical reports discuss scenarios in which certain versions of the platform could lift loads weighing more than 5 tons. This means the robot could perform work that currently requires specialized machinery. Moreover, thanks to its humanoid design, it would be able to operate in environments originally created for humans without requiring a complete redesign of existing infrastructure. If such a project really exists, its cost at the initial stage could be extremely high. Some analysts estimate that the price of the first units could range from $250,000 to $500,000 per unit. However, Tesla's history shows that the company traditionally focuses on scaling production and reducing manufacturing costs. Therefore, after several years, the price could decrease significantly. Interestingly, the potential emergence of such robots is already raising questions among regulators. If an autonomous machine is capable of moving multi-ton loads, many new legal and technical issues arise. Who will be responsible for a robot's mistake? What safety requirements should apply to such systems? How should a machine be certified when it simultaneously functions as a vehicle, industrial equipment, and an autonomous AI system? Experts also point to the social consequences. If heavy industrial robots become widespread, many professions may begin to change rapidly. This concerns not only loaders or warehouse workers. The transformation could affect construction, mining, logistics, manufacturing, and many other industries. Some specialists believe this could represent the largest transformation of the labor market since the Industrial Revolution. At the same time, supporters of these technologies point out the positive aspects as well. Many countries are facing a shortage of qualified workers. The population is aging. Younger generations are increasingly less interested in physically demanding professions, and industries continue to face labor shortages. In such a scenario, robots may not completely replace humans, but instead fill critically important positions that remain vacant. Another important issue is energy consumption. A machine of this scale would require enormous amounts of power. Therefore, some experts believe Tesla may be developing new battery solutions specifically for heavy-duty robots. It is possible that future industrial versions could use replaceable battery modules or automated charging and battery swapping stations. When could such a robot be introduced? If we look at the pace of Optimus development and consider the traditional timeline required for complex engineering projects, the first demonstration prototypes could appear closer to the end of the decade. Some analysts believe early concepts could be revealed much sooner in order to demonstrate the direction of the technology and attract corporate customers. If such a project is actually realized, its consequences could be enormous. For the first time in human history, there would be a universal mobile machine capable of performing heavy physical work in an environment designed for humans. This could transform urban construction, factory operations, port logistics, resource extraction, and even the exploration of other planets. It is no coincidence that many specialists view robotics as the next trillion-dollar market after artificial intelligence. If electric vehicles became the revolution of transportation, humanoid robots could become the revolution of physical labor. And if Tesla is indeed working on a heavy industrial version of Optimus, it could become one of the most ambitious projects in the company's entire history. While there is currently no official confirmation of such a project, the number of rumors and discussions continues to grow. This means it is entirely possible that in the coming years, the world will see not just a new robot, but the beginning of a completely new industrial era, where massive intelligent machines become as common a part of the economy as trucks, cranes, and factory assembly lines are today. In recent months, events have begun unfolding around Apple that until recently seemed impossible even to the boldest analysts in Silicon Valley. The company, which for decades has been associated with smartphones, computers, and software, has reportedly begun a transition toward an entirely new product category that could change not only the technology market, but also the everyday lives of billions of people. The subject is Apple's first humanoid robot, and although the company officially continues to remain silent, the number of indirect signs has become so significant that many experts are already comparing what is happening to the period when Apple was secretly preparing the first iPhone. It all began with a series of reports from renowned analyst Ming-Chi Kuo, who is considered one of the most authoritative insiders in the Apple ecosystem. He was among the first to reveal that the company was actively exploring not only non-humanoid robotic systems for the home, but also full-scale humanoid platforms. At the time, many viewed this information as a long-term experiment that might never leave the laboratory stage. However, as new data began to emerge, the picture started changing rapidly. According to sources within the supply chain, Apple significantly increased budgets for divisions connected with robotics, computer vision, and artificial intelligence. Moreover, several former company employees told journalists that inside Apple, robotics is no longer viewed as a secondary research direction. On the contrary, it is beginning to take a place alongside artificial intelligence and wearable electronics on the list of strategic projects for the next decade. Analysts were especially interested in Apple's scientific publications from recent years. The company began actively publishing research focused on robot learning, spatial perception of the surrounding environment, machine interaction with the physical world, and new approaches to robotic AI. At first glance, this looked like ordinary academic activity, but specialists quickly noticed an unusual pattern. Most of these studies are ideally suited for creating a humanoid platform capable of moving through human environments, understanding the owner's commands, and performing real-world household tasks. Some experts even suggested that Apple may effectively be publishing separate elements of its future technology long before an official announcement. The situation became even more interesting after reports of major changes inside the company's robotics division. According to several industry publications, Apple underwent leadership changes in a number of research groups connected with robotics and artificial intelligence. Such personnel shifts usually occur when an experimental development moves into the stage of preparation for a commercial product. That is why many analysts began asking the question, what if Apple has already decided to create its first humanoid robot and is now gradually building a team to bring it to market? Even more intriguing are the reports coming from component suppliers. According to rumors, the company is testing new types of actuators, compact electric motors, and power systems that differ significantly from the solutions used in traditional consumer electronics. Sources claim that some of these technologies are intended for a device that must actively move through space, lift objects, interact with people, and perform physical work. When journalists attempted to find out what exact product was being discussed, most sources refused to comment, but several people hinted at a project that inside the company is considered the most ambitious since the first iPhone. According to several analytical firms, Apple is closely monitoring what is happening in the humanoid robotics market. The company is paying especially close attention to the progress of Tesla Optimus, developments from Chinese manufacturers, and research conducted by leading Japanese corporations. Apple's leadership understands perfectly well that the world is gradually approaching a moment when robots will begin appearing in people's homes on a massive scale. And if the main computing device was once the computer, followed by the smartphone, then the next step could become the personal robotic assistant. That is why the idea of creating a device that would become the physical embodiment of the Apple ecosystem is increasingly being discussed inside the company. According to sources familiar with internal corporate discussions, the future robot is being viewed not simply as a household assistant. The assumption is that it will become a full-fledged digital companion for the user. It will be able to understand context, remember the owner's preferences, accompany a person around the home, control smart devices, assist with work and learning, and perform dozens of everyday tasks. Some analysts are already calling such a concept the next iPhone moment for the entire technology industry. Interestingly, these discussions appeared almost simultaneously with Apple's major strategic restructuring in the field of artificial intelligence. After launching Apple Intelligence, the company faced extremely intense competition from OpenAI, Google, and other market players. That is why many experts believe Apple may attempt to focus on an entirely new category of devices where its strengths will become especially visible. If smartphones became the defining device of the mobile internet era, then humanoid robots could become the defining device of the artificial intelligence era. According to several insiders, one of Apple's research centers already has working prototypes of systems capable of recognizing objects, navigating through space, and interacting with the surrounding environment at almost human-like levels. Of course, this is not yet a finished product, but the very existence of such projects has generated enormous interest among investors. Some Wall Street analysts have begun suggesting that robotics could become the next multi-trillion-dollar market, where Apple attempts to repeat the success of the iPhone. The possible design of the future device also looks particularly interesting. According to sources, Apple is considering several different concepts for its appearance. These include compact home assistants with screens and wheeled platforms, as well as fully humanoid systems capable of walking on two legs. At the same time, the humanoid direction has recently been receiving increasing amounts of resources. This has led many observers to believe that the company sees long-term potential specifically in human-like robots. Against this background, rumors are increasingly emerging that Apple is forming a secret next-generation project designed to combine the company's achievements in artificial intelligence, robotics, computer vision, voice technologies, and wearable electronics. Some employees allegedly describe it as the most complex engineering challenge in the company's history. If these reports are even partially accurate, the world may be approaching the emergence of Apple's first humanoid robot, a machine capable of changing the way people imagine what a personal assistant of the future should be. As the number of leaks continued to grow, the attention of industry analysts began shifting from the question of whether Apple is working on robots to the question of how far this development has actually progressed. And this is where the most interesting details began to emerge. Several sources who had previously provided accurate information about new Apple products told journalists that the company allegedly has a separate program dedicated to creating a next-generation universal home robot. According to these sources, the project is viewed by Apple's leadership as a potential launch of the same importance as the first iPhone and could determine the company's direction for many years ahead. Particular interest was generated by reports that Apple has allegedly begun testing new generations of its own processors, specifically adapted for robotic systems. While the A-series and M-series chips were originally designed for smartphones, tablets, and computers, company engineers are reportedly now working on computing solutions capable of processing massive amounts of information from cameras, lidars, microphones, and other sensors in real time. Sources claim that the future robot must perceive the surrounding world almost the same way a human does, instantly analyzing what is happening around it and making decisions without constant connection to cloud servers. Many specialists have noted that such an approach fits perfectly with Apple's overall philosophy. The company has always aimed to move as much computing as possible directly onto the device, providing high levels of privacy and speed. That is why analysts believe Apple's future robot could perform a significant portion of its tasks locally without sending users' personal data to remote servers. This approach could become one of the product's key advantages compared with competitors. Meanwhile, new rumors surrounding the project have continued to appear. Several insiders reported that Apple is actively recruiting specialists from leading robotics companies around the world. In particular, the reports allegedly involve engineers with experience in autonomous navigation systems, industrial robots, and machine vision algorithms. According to observers, such hiring activity usually indicates that a project has entered a more serious development phase, when a company begins assembling the expertise required to prepare a product for future mass production. It is also interesting that these reports appeared at the same time as information about the expansion of Apple's research laboratories. Some sources claim that the company is investing significant resources into creating new testing facilities where robotic systems can learn how to interact with real-world objects. These are reportedly not just laboratories filled with sensors and computers, but full-scale replicas of living spaces, kitchens, living rooms, and working environments. According to insiders, such facilities allow robots to be tested in conditions that are as close as possible to real life. Against the background of these developments, some journalists began comparing the situation with the way Apple prepared the launch of the first Vision Pro. At that time, the company also worked on the technology behind closed doors for many years, and information about the actual state of the project appeared only in fragments. However, in the case of robots, the potential scale could be significantly larger. If a mixed reality headset remains a niche device for a specific audience, a robotic assistant could potentially enter almost every home. In the world of high technology, there are rarely projects surrounded by such a combination of expectations, rumors, insider reports, and debates as Tesla Optimus. While most people still perceive humanoid robots as something from science fiction, inside Tesla, work has been underway for several years on what Elon Musk has repeatedly called one of the most important products in the company's history. And if just a few years ago, Optimus looked like an experimental prototype capable of performing only the simplest actions, today, the situation is changing literally before our eyes. According to numerous publications in the technology press, statements from Tesla itself, and assessments from industry analysts, the company is gradually approaching the next stage in the development of its robot, which could turn out to be far more significant than many expect. What makes this especially interesting is the fact that in recent months the number of leaks, insider reports, and discussions surrounding the next version of Optimus has increased noticeably. Analysts tracking Tesla's supply chains note that the company is actively increasing purchases of components related to sensor systems, computing modules, and next-generation actuators. Some experts suggest that Tesla is currently in the final stages of preparing another major Optimus platform update that could significantly change people's perception of what the humanoid robot of the future should look like. But while earlier most attention was focused on the robot's mechanics and its ability to perform physical labor, reports are now increasingly appearing about another direction of development. According to several industry observers, Tesla is becoming more focused on the robot's appearance and on how comfortable people will feel interacting with the machine in everyday life. Many specialists believe that the psychological factor will become one of the most important elements in the success of future humanoid robots. People are much more willing to trust a system that looks friendly and understandable than a device that resembles an industrial machine. Therefore, it is not surprising that rumors are increasingly appearing that Tesla may be working on creating a more human-like design for Optimus. This is not only about the external shape of the body, but also about more complex solutions. In particular, some analysts suggest the possibility of new materials capable of imitating the texture of human skin. Such technologies already exist in robotics and are used by research laboratories around the world, but their mass adoption remains an extremely difficult challenge. Nevertheless, the idea of making human-robot interaction more natural looks quite logical from the perspective of the company's long-term strategy. Another area of interest is the topic of Optimus's future face. At the moment, Tesla's robot uses a minimalist design with a black face panel. This approach preserves a recognizable appearance and simplifies the construction. However, some specialists believe that in the future, Tesla may begin experimenting with more advanced facial systems. Creating a fully human-like face is one of the most difficult challenges in modern robotics. It requires a complete redesign of the placement of sensors, cameras, cooling systems, and computing components. In addition, it is necessary to ensure realistic transmission of emotions, facial expressions, and movements. This is why, even if Tesla is truly exploring such a direction, expecting a completely realistic human face to appear in the near future would be premature. However, the very possibility of such a development is already being actively discussed within the technology community. Moreover, some experts suggest that in the future, the company may offer different options for robot appearance customization. Just as today customers choose the color of a car or interior configuration, Optimus owners could potentially choose the external appearance of their personal assistant. Another equally important area remains the robot's hands. The hands are considered one of the most difficult elements of humanoid construction. According to Tesla, the company is constantly improving its finger control system, increasing movement precision, and expanding the ability to perform delicate manipulations. According to analysts, the next generation of Optimus could receive significantly more dexterous hands, capable of handling fragile objects almost at a human level. This would open the way for a huge number of new applications, from household assistance to equipment maintenance, medical logistics, and industrial assembly. However, many specialists believe that the main upgrade of future Optimus will not be its appearance or even its mechanics. The key factor will be artificial intelligence. After the release of new versions of Grok and the rapid development of xAI's computing capabilities, more and more experts are saying that intelligence itself will become Tesla's robots' main advantage. If current versions of Optimus are mainly trained to perform specific tasks, then in the future, the robot will need to understand the surrounding world much more deeply, build long-term plans, and adapt to new situations without constant retraining. Essentially, this represents a gradual transition from a robot as a tool to a universal digital assistant, capable not only of executing commands, but also of understanding human intentions. Many analysts compare this process to the transition from mobile phones to the era of smartphones. Once, phones could only make calls. Then applications, the internet, and artificial intelligence appeared. Now a similar transformation may await robotics. This is why Elon Musk has repeatedly emphasized that in the long term, Optimus could become Tesla's most mass-produced product. Some estimates suggest that if successful, the humanoid robot market could become many times larger than the automotive market. Robots could work in factories, warehouses, stores, hotels, logistics centers, and even private homes. At the same time, the cost of operating such an assistant will gradually decrease as technology advances and production volumes increase. The question of timing remains one of the most widely discussed topics. Despite numerous rumors, Tesla itself has not yet announced a specific date for the arrival of a so-called human-like version of Optimus. Most analysts agree that in the coming years, the company will focus on large-scale deployment of current robot generations inside its own facilities. This is where Optimus will be able to be tested under real operating conditions, collect enormous amounts of data, and continue improving through training. Nevertheless, some specialists believe that the first noticeable design changes could appear in the next generations of the robot. More advanced human-like elements will likely become part of a long-term strategy during the second half of the decade. Everything will depend on progress in artificial intelligence, materials science, batteries, and manufacturing technologies. The price remains a separate topic. Today, most experts assume that Tesla's long-term goal is to reduce the cost of Optimus to the level of an affordable car. Elon Musk previously mentioned a target range of around $20,000 to $30,000 in the case of mass production. However, early versions for the external market, if they appear in the coming years, could be significantly more expensive due to limited production volumes and high component costs. But even if the price remains high, many analysts believe demand will be enormous. The reason is simple. Humanity is facing labor shortages in many countries. Populations are aging, the number of working-age people is declining, and demand for services continues to grow. Under these conditions, humanoid robots are gradually becoming not just an interesting technology, but a potential solution to a global economic challenge. At the same time, many specialists believe that the real transformation will not begin when Tesla teaches the robot to perform new physical actions, but when Optimus is able to fully understand the surrounding world almost as naturally as a human does. This is where the development of Grok artificial intelligence comes to the forefront, becoming one of the key elements of Elon Musk's entire strategy. Today, many analysts view Tesla not simply as an automotive company or a robot manufacturer. Increasingly, it is being described as an artificial intelligence ecosystem in which vehicles, supercomputers, data centers, robots, and language models are gradually being combined into a single infrastructure. According to several Silicon Valley experts, this integration could give Optimus a major advantage over competitors. Most existing humanoid robots still operate within relatively narrow scenarios. They are capable of performing predefined actions but struggle when they encounter unexpected situations. Tesla, however, is betting on versatility. The robot should not simply repeat movements but understand the context of what is happening around it. If a person asks it to rearrange furniture, prepare food, help an elderly relative, or perform a complex sequence of actions inside a home, the system should be able to independently create a plan for completing the task. This is why increasing attention is being paid to training robots on enormous volumes of data. Some analysts suggest that in the future, Optimus could use the experience of millions of other robots around the world. If one robot learns how to perform a new task, the collected data could be used to train the entire network. Essentially, this means creating a collective intelligence where every new experience becomes available to the entire system. Such an approach could lead to robot development progressing much faster than many expect today. If in the past, learning a new skill could take months, in the future, the spread of new capabilities could happen almost instantly through software updates. This means that a robot purchased by a person today could have a completely different level of abilities several years later without the need to buy a new device. China is officially entering a new era, an era that just a few years ago many considered science fiction, an era in which humanoid robots are gradually ceasing to be laboratory experiments and are beginning to become a fully integrated part of the economy of the world's largest manufacturing power. In recent months, global media attention has been focused on the Chinese company UB Tech, which has introduced a new generation of humanoid robots in the U1 series. Their emergence has created major global attention not only within China, but far beyond its borders. Analysts describe this development as the beginning of a new industrial revolution, comparing the significance of humanoid robotics to the rise of the internet, smartphones, and artificial intelligence. For decades, humanity has dreamed of creating a machine capable not only of executing individual commands, but of fully interacting with the surrounding world in the same way a human does. A robot that can see, understand speech, analyze its environment, make decisions, and perform complex tasks in real physical space. For a long time, such projects remained purely scientific experiments. However, today, the situation is changing rapidly. According to forward-looking forecasts from several research institutions, China may become the first country in the world where humanoid robots begin to be deployed at scale not as isolated demonstration projects, but within the real economy in the coming years. The reason is simple. China has the largest manufacturing base on the planet, enormous computing capacity for artificial intelligence development, and vast financial resources for implementing new technologies. The emergence of the U1 series is seen by many experts as a symbol of this transition. The new generation of robots has been designed with a form that closely resembles the human body. Their height is comparable to that of an adult human. They are capable of maintaining long conversations, recognizing the emotions of people they interact with, analyzing their surroundings using dozens of sensors and cameras. and adapting to new situations through advanced artificial intelligence systems. But the most interesting aspect is not their appearance. The main question being discussed today by investors, engineers, and governments around the world is different. What happens if such robots become cheap enough for mass production? Imagine China 10 years from now. Massive logistics centers where thousands of humanoid robots sort cargo around the clock. Factories where most routine work is performed by autonomous machines. Hotels, shops, airports, and hospitals where a significant share of tasks is handled by next-generation intelligent assistants. For the economy, this could mean a sharp increase in productivity and a reduction in costs across almost all sectors. Some futurists go even further. They suggest that after reaching a certain scale of production, the cost of a humanoid robot could fall so much that it becomes affordable for ordinary families. In that case, the robot would no longer be industrial equipment and would instead become a household device, much like computers once stopped being tools of large corporations and eventually entered almost every home. However, alongside these opportunities come new risks. Regulators in different countries are already discussing future laws that should define the rights and responsibilities of owners of such systems. Who will be responsible for the actions of an autonomous robot? What data will it be allowed to collect? How deeply will artificial intelligence be allowed to participate in decision-making? Where is the boundary between a useful assistant and a technology capable of reshaping the labor market beyond recognition? The issue of employment is particularly serious. Economists warn that the mass deployment of humanoid robots could lead to the largest transformation of the labor market in modern history. Millions of professions may change. Some jobs may disappear entirely. At the same time, entirely new fields of activity will emerge, fields that do not yet exist today. History shows that every technological revolution has created more opportunities than it has destroyed, but the transition period has always been accompanied by significant disruption. This is why many observers believe that the race to develop humanoid robots has already become a new technological competition between the world's leading powers. China, the United States, South Korea, Japan, and Europe are investing billions of dollars into the development of artificial intelligence and robotics. The winner of this race could gain an enormous economic advantage for decades to come. If the predictions of technology advocates prove correct, then the current generation will witness one of the most profound transformations in the history of civilization, a transformation that will not begin with the emergence of new smartphones or computers, but with the appearance, alongside humans, of intelligent machines that are visually almost indistinguishable from people. At the same time, the most interesting question may not even be how many robots China will be able to produce. A far more important issue is what will happen when these machines begin to learn from one another. Today, most modern artificial intelligence systems are already capable of analyzing enormous volumes of information, identifying patterns, and improving their skills far faster than humans. If such intelligence is combined with the physical body of a humanoid robot, a completely new situation emerges, one that humanity has never faced before. Imagine a vast network of millions of humanoid robots across China. One robot learns a better way to sort goods in a warehouse. Another discovers a more efficient method of serving customers in a hotel. A third learns how to repair industrial equipment more quickly in a factory. Thanks to cloud technologies and centralized learning systems, this experience can be instantly distributed across the entire network. In effect, every new skill learned by one robot becomes a skill available to millions of other machines. This is why some experts describe such systems as a new generation of collective intelligence. A human learns over years. A robotic network could potentially learn across an entire country in a matter of hours. If such a model truly works in practice, the speed of technological progress could become dramatically higher than anything seen before. Special attention is currently being paid to the cost of such devices. According to several analysts, price will be the key factor determining how quickly humanoid robots spread. Early models are always expensive. It was the same with computers, it was the same with smartphones, it was the same with electric vehicles. But history shows that once mass production begins, the cost of technology tends to fall rapidly. many investors are already drawing parallels with the early 20th century automotive industry. At that time, cars were considered a luxury for the wealthy. No one could imagine that within a few decades, millions of people would own their own vehicles. Today, similar discussions are emerging around humanoid robots. Some forecasts suggest that in the future, the price of a basic model could become comparable to that of a modern mid-range car. If such a scenario materializes, the consequences would be enormous. For the first time in human history, every family could potentially afford a helper capable of performing dozens of different tasks. House cleaning, cooking, caring for elderly relatives, childcare, home security monitoring, appliance maintenance, shopping, and delivery could all gradually be transferred to robotic systems. For China, this development has particular importance. The country is facing an aging population. The number of elderly people is steadily increasing, while the number of young workers is declining. This demographic challenge is considered one of the main threats to long-term economic growth. As a result, robotization is increasingly seen by many Chinese strategists not merely as a technological project, but as a tool for maintaining the future competitiveness of the economy. According to some estimates, China could face a shortage of millions of workers across various industries by the middle of the next decade. Humanoid robots are viewed as one possible solution to this labor gap. If a machine can perform human work around the clock, without vacations, sick leave, or weekends, its economic attractiveness becomes obvious to businesses. However, this is precisely where the most difficult questions begin. What will happen to millions of people whose professions are threatened by automation? What will cashiers, warehouse operators, logistics staff, administrators, consultants, and dozens of other professions do if a significant share of their responsibilities is taken over by machines? Some experts believe these concerns are overstated. They remind that every technological revolution has been accompanied by fears of mass unemployment. When tractors appeared, people feared the disappearance of agricultural professions. When computers emerged, many predicted a catastrophe in the labor market. But in the end, the economy adapted and created new jobs. Other analysts take a more cautious position. In their view, artificial intelligence and humanoid robotics differ from all previous technologies in that they are, for the first time, beginning to compete not only with human physical labor, but also with human intellectual capabilities. This means the scale of change could be significantly more profound. Equally important remains the issue of regulation. Governments in many countries are already discussing possible restrictions on humanoid robots. It is necessary to define rules for their use in public spaces, safety requirements, standards for personal data protection, and mechanisms of accountability for the actions of autonomous systems. The more realistic robots become, the harder it becomes to distinguish a human from a machine. And this factor alone could generate numerous new social and legal problems. Imagine a situation where in a shopping mall, airport, or hotel, there are dozens of next-generation humanoid robots around you. Externally, they are almost indistinguishable from humans. They are able to hold conversations, recognize emotions, joke, help solve problems, and interact with people in a highly natural way. For most visitors, it may be extremely difficult to determine whether they are dealing with a human or a machine. Some futurists believe that this moment will become a psychological turning point for society. Humanity will, for the first time, encounter beings that look like humans, behave like humans, and speak like humans, but are not human. And no one yet knows what the long-term effects of such coexistence will be. The global robotics market is experiencing a tectonic shift, the scale of which humanity has not yet fully realized. The world's leading laboratories, which have spent years competing to create anthropomorphic machines, acknowledge that the humanoid robot race has officially entered a new phase, and the rules of the game are now being set by one undisputed leader. According to confidential reports from Silicon Valley insiders and publications in respected outlets such as Bloomberg and MIT Technology Review, Boston Dynamics has achieved a technological breakthrough that experts are already calling the iPhone moment for the artificial intelligence and mechatronics industry. Their main and most ambitious project, the updated fully electric humanoid Atlas, has received a package of critical upgrades that has stunned leading engineers around the world and forced giants such as Tesla, Figure, and Unitree to urgently reconsider their strategies. Until recently, it seemed that Boston Dynamics was losing the commercial market to ambitious startups, and many analysts mistakenly viewed the retirement of the old hydraulic version of Atlas as a surrender in the face of Tesla Optimus's rapidly growing project. However, the reality turned out to be completely different, because the company had simply entered a period of extreme secrecy in order to completely rebuild the robot's architecture from the ground up. The new commercial electric Atlas, presented at closed industrial exhibitions, did not simply return to the competition. It effectively destroyed the very concept of competition by demonstrating capabilities that were previously considered theoretically impossible for a bipedal machine. What made engineers from NASA, Boston Dynamics, and robotics specialists from the University of Tokyo literally question everything was Atlas's new kinematics and physical parameters. The robot received an incredible 56 degrees of freedom, making its mobility almost twice as advanced as that of a human. Instead of imitating the clumsy human-like walking used by competitors, Atlas uses a concept of superhuman maneuverability. Its joints and articulated mechanisms, created around custom electric actuators in close partnership with Hyundai Mobis, are capable of rotating 360 degrees. The robot can turn its hips, neck, or shoulder structure in any direction without wasting time rotating its entire body, completely changing the traditional understanding of movement ergonomics. According to the specialized publication IEEE Spectrum, industry insiders were amazed by demonstrations of the so-called proprioception effect and the overcoming of the gap between simulation and reality. In recent tests, Atlas demonstrated the ability to perform precise maneuvers on slippery, dynamically changing surfaces, execute highly complex professional football-style moves, including a Rabona kick, and instantly restore balance after a powerful external impact. At the same time, its industrial payload capacity reached an impressive 50 kilograms of continuous load. The robot can independently lift a large refrigerator or a heavy automotive body component, rotate 180 degrees on one leg, and carefully place the load onto a conveyor without the slightest indication of mechanical instability or loss of balance. For heavy industry, the platform's durability has become critically important as the robot is protected according to the IP67 standard, allowing it to operate in heavy rain, highly dusty environments, and extreme temperatures ranging from -20 to +40 degrees. But the main engineering triumph, according to technical insiders, is the autonomous power replacement system. Unlike Optimus, which requires a long stationary charging process at a wall-mounted station, Atlas, controlled by the proprietary Orbit software, automatically moves to a station when the battery level drops, removes the depleted battery, replaces it with a fully charged one, and immediately returns to operation, enabling a continuous 24/7 working cycle. The explosive growth in Atlas's capabilities has not gone unnoticed by the leading figures in the high-tech industry. According to sources in Silicon Valley, Tesla CEO Elon Musk was deeply shocked by the latest closed demonstrations from Boston Dynamics. Publicly, Musk has always stated that Tesla Optimus would become the most valuable product in human history, capable of raising the company's market capitalization to tens of trillions of dollars. However, according to insiders, after Boston Dynamics engineers demonstrated the integration of Atlas's physical body with the latest neural network models, Musk called an emergency meeting of the Tesla AI team. The comparison between the two flagship robots today appears to be clearly unfavorable for Tesla. While the second-generation Optimus still demonstrates relatively slow, strictly anthropomorphic movements and has only around 28 degrees of freedom with a payload capacity of up to 20 kilograms, Atlas surpasses it in strength, limb reach, extending up to 2.5 meters, and speed of adaptation. Optimus requires months of training in a virtual environment for each specific task, while Atlas, thanks to Boston Dynamics' revolutionary strategic partnership with Google DeepMind, is connected to advanced multimodal vision language models. The new cognitive module based on a customized Google Gemini robotics architecture allows Atlas to learn a completely new industrial task in less than 1 day. The robot only needs to watch a demonstration video or observe the actions of a human operator for its neural network to instantly break down the task, adapt it to its 56 degrees of freedom, and begin performing the operation accurately in a real factory environment. What shocked Musk most was precisely this speed of intelligence evolution, because Atlas was no longer just a machine executing strictly programmed algorithms. It had acquired a full physical AI capable of making decisions on the fly in a chaotic and unpredictable human environment. The main question now facing the global economy is how the arrival of commercial Atlas will transform industry and the labor market. Experts at the Wall Street Journal agree that humanity is approaching the greatest wave of automation in history. The first sectors affected will be logistics centers, automotive factories, and warehouses. The parent company Hyundai Motor Group has already officially approved a global robotics strategy, under which tens of thousands of Atlas units will be deployed at factories in the United States and South Korea by 2028. The robots will completely replace humans in the most dangerous, exhausting, and repetitive areas, such as automotive component sequencing, pressing operations, heavy lifting, and work in toxic painting environments. The key factor in this technological revolution remains the cost. During the initial production phase, which is expected to begin around the transition between 2026 and 2027, the production cost and final commercial price of Atlas will be high, reaching approximately $150,000 per unit. This is significantly more expensive than Chinese alternatives such as Unitree G1 or the planned retail price of Optimus. However, the economic value of Atlas is calculated differently because thanks to its exceptional reliability, zero downtime due to automatic battery replacement, and a zero level of workplace injuries, large companies could recover the cost of purchasing such a robot in less than 1.5 years of operation. At the same time, insiders claim that Boston Dynamics is deliberately avoiding the consumer market at this stage. Unlike Figure or 1X Neo, which are positioned as home assistants, Atlas is being created exclusively as an industrial titan certified under strict corporate safety standards. Ordinary consumers will not be able to order it for household cleaning or grocery shopping in the coming years. The company is focusing on the B2B segment, aiming to reach mass production volumes of up to 30,000 units per year by 2028, distributing deliveries through pre-arranged contracts with the world's largest automakers and logistics giants. A world in which millions of anthropomorphic machines possess physical strength beyond human capabilities and intelligence capable of self-learning carries enormous existential risks. Leading analytical centers are already raising alarms about mass unemployment among low-skilled workers. If Atlas can replace 3 loaders or assembly workers while operating 3 shifts a day without lunch breaks, sick leave, or labor unions, this could lead to a massive social imbalance and force governments to consider introducing the concept of universal basic income. The second and equally alarming aspect is the autonomy of intelligence. Integration with Google DeepMind models gives Atlas an extremely high level of situational awareness. The robot is equipped with a 360-degree machine vision system, LiDARs, and tactile sensors in its fingers, capable of detecting pressure down to fractions of a gram. If such a system were to experience a failure in its central neural network or become the target of a large-scale cyber attack, the consequences could be catastrophic. That is why Boston Dynamics is implementing multi-layered hardware safety mechanisms independent of the primary AI system, which physically disable the robot's actuators when a person is detected within a critical proximity zone. Nevertheless, the momentum of progress has already begun. In the coming years, Atlas and its successors will transform the appearance of global cities, ports, and factories. Industry will permanently move beyond the concept of the human factor in heavy labor. Humanity, meanwhile, will have to adapt to a new reality where a being walking beside us on the factory floor possesses a cold silicon-based intelligence, perfect balance, and the ability to learn faster than any living organism on the planet.